Welcome. I'm Vybava Ramadoss, and with me today is Aung, the Vice President of Product for Azure Storage, Azure Databricks, and Azure Data Manager for Energy. Today, we're going to talk about how storage is evolving for AI, what's changing, what new challenges it brings, and how we as Azure are responding across the platform. Storage has always been a foundational infrastructure. As AI becomes a big part of enterprise strategy, how is that changing what customers need from storage?
Storage has three product categories: block, object, and fast storage, offering purpose-built capabilities for every workload. The important thing is that storage was never a single purpose. AI adds a new profile on top of what's already there. Storage already underpins multiple workload patterns, cloud-native applications, modernization of existing estates, and large-scale analytics. AI doesn't replace those requirements. It changes the demands on storage, heavy throughput, and massive scale at enterprise grade. A useful mental model is that you train a model periodically, but you run inference every single time someone prompts Copilot, GitHub Copilot, or an agent. So inference is the workload running constantly, and it leans really hard on storage. Data governance is also very critical to enterprises. Enterprises own the data and need a complete control on how the data is used with AI. This is a distant value proposition from Azure and storage. And also important to note that it is not one model maker. Azure is home to OpenAI, Microsoft-owned MAI models, Anthropic, and open source models. Every one of them needs a fast, secure data layer underneath.
What is the customer journey with AI workloads at Microsoft?
That's a good question. Enterprise can run AI in different ways in parallel. Manage on Microsoft Foundry, on AKS for teams who want framework control, and directly run on IaaS for custom and hyperscale builds. For IaaS and platform teams specifically, the job is to make storage consistent and high performance across all three paths, so the data layer never constrains the choice.
That's very interesting. When you look at modern AI workloads, especially agents running at scale, what changes about the storage requirements?
The nature of AI workloads shifts decisively toward performance and scale. Three demands stand out for me. First, bringing enterprise data into AI systems as governed knowledge. AI workloads are fundamentally data pipelines, including ingestion, cleaning, chunking, embedding, and indexing, all anchor in Azure Storage. That intermediate data, embeddings, chunks, and indexes, lives in storage and must be retrieved in milliseconds to ground every prompt and agent interaction. Second is feeding GPUs efficiently through fast model and data access. The constraint isn't just having data, but how fast storage can deliver it into GPU. AI workloads depends on high throughput data movement for training checkpoints and inference time retrieval at distributed scale. Lastly, optimizing inference economics at scale. Inference is now the dominant workload that we observe, and every agent interaction multiples storage demand with more reads, more state, and more logs. Storage directly determines GPU utilization, latency, cost efficiency driving tokens per word and per dollar. As I mentioned, training happens periodically, but inference runs continuously with every Copilot prompt, every agent loop, and every turn increases pressure on storage to deliver data faster, cheaper, and at scale. That's why Azure Storage is no longer just persistence, but becomes a system that turns enterprise data into usable AI knowledge, keeps GPUs fully utilized instead of waiting on data, and determines the overall efficiency of AI systems.
And these requirements land squarely on the infrastructure teams on the customer side.
These are throughput and scale problems, exactly where infrastructure platform owners operate. And the priority for those teams isn't only new AI apps. It's using storage to modernize the existing estate so it can participate in AI, turning data they already have into an AI-ready asset.
Where does Azure Storage fit into Microsoft's broader AI platform priorities?
We are investing across the entire path from data inference, not just as a single feature, but as an integrated system. If you look at the architecture on screen, it maps to 3 layers. First, bringing enterprise data into AI systems. AI workloads are fundamentally data pipelines with ingestions, preparation, chunking, embedding, and indexing. Azure Storage sits at the center of that pipeline, where raw data is transformed into structured, retrieval-ready knowledge. Data is stored as raw and processed assets in blob, converted into chunks and metadata, indexed into vector database for similarity search and retrieval, and accessed with secure low-latency reads. What customers are really asking for is governed, secure access to their enterprise data so AI system can use it safely. That's what enables agents to ground every prompt in enterprise data, not just models. Second, fast, predictable data access during inference. Once you enter the agent loop, every interaction becomes retrieve, augment, reason, and response cycle. On that front, Azure Storage delivers hundreds of gig read and write throughput for data preparation and sub-10 millisecond latency for retrieval at inference time. This directly maps to what customers need. High throughput at scale to keep GPUs fed, low latency to reduce time to first token, also known as TTFT, consistent performance across vector lookup, prompt augmentation, and agent state. At that point, storage isn't just holding data. It's actively participating in every inference request, ensuring GPU stay utilized and responses remain fast. Third, deep integration into the AI ecosystem. From the second slide, this only works because storage is not isolated. Rather, it directly integrates across first-party platforms like Azure AI Foundry, Azure AI Search, and Azure OpenAI. In open source model partner ecosystems like LangChain, Pinecone, VLLM, and orchestration frameworks. What customers are asking for here is flexibility without friction. Developers can access enterprise data in Azure Storage natively from their AI frameworks. Models can read from storage without custom pipelines. And the same data foundation works across platform as a service, Kubernetes, and infrastructure as a service path. So they don't have to re-architect based on how they deploy AI.
So what can infrastructure as a service teams get in their hands today?
A broad set spanning data access, model loading, inference, and management. Azure Context Cache, currently in private preview with Foundry, offers durable, tenant-owned prompt caching that cuts inference cost. Azure Blob as a first-class knowledge source for Foundry, with vector and hybrid indexing for grounded retrieval. Azure Files is integrated into Azure AI Search, generally available now, and then it turns SMB file shares and lift and shift estate into AI-ready, searchable knowledge, no rebuild required. Azure Native Files, also known as ANF, offers Object REST API, enables customer to bring enterprise file data natively to Azure. Storage Center, a unified hub to manage the full storage estate and connect it to AI.
If An enterprise leader can take one priority away. What is it?
That's a great question. Start where your data already lives. The first step value is connecting your existing estate, blobs and files into AI Search and Foundry, then layering inference optimizations on top. It's incremental. None of this requires re-architecting what you run today.
When we look at the bigger strategic picture, where does this go 1 or 2 years from now?
Storage is increasingly solving the hard, unique problems that underpin Microsoft's own AI investment. The same foundation that make Copilot and Foundry perform at scale are what we bring to customers. Consistency across deployment paths, the same enterprise-grade capabilities, whether you are on Foundry, AKS, or IaaS. And the next chapter is AI for storage, using AI to classify data, manage lifecycle, and operate the estate itself. So much of today's manual governance becomes automatic. The takeaway for leaders, your storage strategy and your AI strategies are converging, and I would like them to plan them as one.
And none of this happens in isolation. How are we working with the broader ecosystem, both first party and partners, to make AI possible?
Our bet is to meet customers where their data and their tools already are. Azure native data platforms, AKS, Microsoft Fabric, Azure Databricks, Azure Native Files, so analytics and AI sit on a common data foundation. Storage partners, Everpure and Dell, bringing enterprise data closer to AI platform from where it already lives. Open source and silicon, a first-class Azure Blob backend in NVIDIA's NIXL, the Run AI model streamer, and connectors for VLLM, PyTorch, and LangChain, so any framework reaches Azure Storage natively. The principal throughput, no one should have to choose between their preferred AI stack and the storage their organization runs on.
Azure Storage has moved from a foundational layer to a strategic lever for enterprise AI across data access, model loading, inference economics, and modernization.
Yeah, it layers onto what customer already run. The capabilities are available now across first party and partner. This isn't a future roadmap conversation.
Aung, thank you. Explore the latest capabilities on Azure Storage, including Azure Context Cache when using Microsoft Foundry and Azure AI services for AI.
Hey, thanks, Vybava. Thanks for having me here.
Thank you for being with us today, and we welcome your feedback.